Hi guys, we are talking about equations as relations. So if we remember the idea of what an equation is, it's a mathematical expression or sentence that has an equal sign. An equation in two variables is exactly what you think, an equation that has two variables in it. This equation has a y and an x. It could be any two variables. Oftentimes we're going to talk about graphs of these kinds of equations. Solution is any thing, or any, in this case, since we're talking about two variables, any ordered pair that satisfies this equation. So any ordered pair that satisfies this equation is going to be considered a solution, and oftentimes we write our ordered pairs in x, y columns, or we write them as pairs, x comma y. So can you think of some values that would satisfy this equation, the one that I just kind of came up with? If you plugged in like 0 for x, y would have to be 3. If you plugged in 7 for x, y would have to be 2 times 7 is 14 plus 3 would have to be 17. If I plugged in like negative 1/2 for x, yeah, I can plug that in too. If I plugged in negative 1/2 for x, 2 times a negative 1/2 is negative 1. Negative 1 plus 3 is 2. We could do this for a very long time. We could do this forever, in fact. We could do this because there's infinitely many solutions that are going to work here. Some solutions don't work. Infinitely many doesn't mean everything works. Let's try a point. Let's say 2, I don't know, 5. If I plugged in 2 for x, that would be 2 times 2 is 4, plus 3 would make 7 and not 5. So this solution is, this ordered pair is not a solution for this particular equation in two variables. So today we're going to talk a lot about what's a solution and what's not a solution when we're dealing with equations with two variables. Here we have an example 1, a situation where we are finding the solution to an equation in two variables, but we're going to use what's called a replacement set. So the replacement set is your textbooks, the author of your textbooks, way of getting you to think about some numbers work and some numbers don't. Or I should say some ordered pairs work and others do not. So we're going to find the solution set, for this particular equation. Now, when it says the solution set, again, there's infinitely many solutions here, so I wouldn't say that it is the solution set, but you at least want to find the values that work. Sorry for splitting hairs on that, but the wording just made me feel a little uncomfortable. So I've got 2x plus 3, and what I'll do is I will try to test to see if this will work by writing these two, leaving x and y blank, plugging it in, and we're going to see if it works. So let's check this first point, negative 2, negative 1. I put a negative 1 in for y, a negative 2 in for x. 2 times negative 2 is going to be a negative 4, plus 3 is going to be a negative 1. This one works. I'm going to try it again. So now that we're getting the hang of it, let me erase these guys. Not all of it, Dion. I'm going to erase these guys and see if we can plug in another number. So let's see if we plugged in 3 for y and negative 1 for x, as that is there. So 2 times negative 1 is a negative 2, plus 3. Nah, that one doesn't work. So I'm going to put an x here. That one doesn't work. Let's see if we can try the next one. So I plug in 4 for y, 0 for x. 2 times 0 is 0 plus 3 doesn't equal 4. So we have another x on that one. So let's try this last point. Plugging in 9 for y, 3 for x. 2 times 3 is 6, plus 3 is 9. Perfect. Perfect. So we see that we have a solution set. So it says find the solution set. Our solution set is going to include only the two values or the two ordered pairs that work. So you'd write your little curly brackets and your solution would look like that. And that's your solution set. This problem asks us to solve using the domain. Now, this is a little tricky because we know domain generally deals with x. We don't have an x here. When you have a situation where they're using other letters, oftentimes you're going to simply assume that it is alphabetical. So A, B will be the point, and therefore A is taking the place of X, and B is taking the place of Y. So they've given us a domain, and we want to find, solve for B, given this domain. We're going to have a whole bunch of different B values, given that these are all possible A values or X values or domain values, right? So I'm going to just go through the list. So I'm simply going to use this table to kind of organize my information. -3, I'm going to plug in for A, and when I do that, I get that B is -3 plus 5, which is 2. I can continue on by plugging in these various values for A, and I would get that in this case, B is 4, B is 5, B here would be 7, and B in this case, when A is equal to 4, would give me 9. So that is now my set of values for B: 2, 4, 5, 7, and 9. In a case like this, when we're given the domain, this here would be called the range. So here we're given another equation. 4x plus 2y is equal to 10, and we're given the domain values, and we remember that domain deals directly with the x values. So I'm going to just literally plug them in right here, and I'm going to find the corresponding y values. What might be nice is if I solved for y. You remember when we did literal equations, we can get y by itself, because that makes it easier to plug in. So that's one way of handling this. You don't have to, but I'm going to try that because I think it's kind of a nice way to handle this. So if I have 4x plus 2y is equal to 10, I'm going to move the 4x over to the other side if I'm trying to get y by itself. When I do that, I get 2y is equal to -4x plus 10. And now I'm going to divide everything by 2, and I get that y is equal to -2x, because 2 divided into -4 is a -2, and 2 divided into 10 is a +5. This equation is equivalent to this equation. They are the same. And so now when I plug in my x values, my equation set up like this will automatically spit out my y values. So if I plug in a -1, -2 times -1 is a +2, plus 5 gives me 7. Plug in a 0, that whole thing goes away because -2 times 0 is 0, plus 5 gives me 5. 2 times that's going to give me a -4, plus 5 gives me 1, and finally 4 times -2 gives me a -8, plus 5 gives me -3. And so here are my ordered pairs. We're supposed to graph this solution set. And here are the 4 points that we have plotted. And if you notice, they kind of seem like they're on a line. And we'll talk a little bit more about that as we continue on with our lessons. But for now, this is it for section 4.4. Let's talk soon. And if you have any questions, let me know. I look forward to talking to you. Take care.